I want to talk about our fellows a little bit. We have a program we've started for the first time this year to have a more formalized fellow or training or internship program for some bright undergraduates. We have a great crop of them this year. They're about 6 weeks, 7 weeks in, and they've learned an incredible amount, and they've done an incredible amount. And one of the things we want to offer to them, not because we're cruel, although maybe they think we are, is the opportunity to speak to you and get some experience speaking about work they've done in public. So with that, I'm going to hand it over to our first fellow, Neha, who's going to talk about where in the world she is or we are. Thank you. We could introduce the next person when you're done.
Okay. Hi, everyone. I'm Neha, and my project has been about answering this question: where in the world am I? And while I would love to stay in this hypothetical introspective space, that is not the space I'm in. I'm currently working mostly in the OS pool, specifically glidins. So my one-line explanation of what a glidin is that a glidin is a job that contains a wrapper script that sets up an execution point on some shared resource. Now, I don't really care about how a glidin really works, but what I do care about is how glidins get information. Now, there's two ways that I know of. It's through discovery and through provided information. The wrapper scripts that a glidin comes with is able to discover information about a worker node's environment. And that discovery can include detecting software such as Singularity or even identifying the operating system on said resource. But on the other hand, we have provided information that comes from human-written configurations, such as things from like the OSG topology repo. And this can provide information such as institutional owners, site names, and resource names. And the main problem is that the current location of a glidin is not currently discovered or provided by the scripts or configurations. One way to define location could be through the institutional owner information, but even though it's sometimes available, a resource a glidin lands on is not always co-located with its owner. So with that, probably one of the obvious ideas is just to use IP geolocation. I could get an IP address from a glidin, and then I can resolve that IP address with a database like MaxMind. And I can determine where a glidin is running in locations such as Alabama or Wisconsin. But a problem occurs when I do IP address geolocation. I deem this as the Kansas problem, and that's because when I have an IP address and it doesn't resolve correctly, I end up returning back a null location for an undetermined IP address. And that for this database itself, it returns back the center of the US. And specifically, it's suggesting that a glidin's operating in the middle of a lake in Kansas, which is just not true. It could be that. So for this problem, I've just discovered that latitude and longitude or an institutional owner is not enough to answer this where in the world am I question. To answer this question, I think I need to define 3 different things. The first thing is location. And for now, I've been defining it as the distance from a glidin to some known point or entity, rather than finding its absolute location. And with that, I also need to define what distance is. Now, it might make sense to make it a physical distance like miles, but I'm defining distance to be from a location to some known entity through network latency or the number of hops returned by something like trace path or trace route. Now, it makes more sense to do something like this because the network paths are not as straightforward as direct lines on a map. And that's because they're more like paths or something like a series of pipes. And the third thing is I need to really rethink this where in the world am I question. And I've been posing it more as where are glidins in relation to known entities? And that's because I'm trying to contextualize the location of glidin in relation to an entity such as a cache or another resource. So what have I been doing these past 7 weeks? I've really been learning how glidins work. I've been seeing how the glidin WMS system works through running OS pool jobs and how it kicks off glidins. I've also been developing these glidin scripts itself to gather network information and advertising this information back to myself. I've also been exploring what software is available to a glidin from a worker node. And then, for example, I mentioned trace path and trace route. It turns out trace path is more available than trace route. And then I've also just been trying to figure out how to answer this where in the world am I question itself. Again, from what you could see, I tried the obvious IP geolocation, but it turns out that's not really useful in this use case. And then I've just been trying to figure out how to use network tools to answer this question. Like I said, I've been using trace path to figure out how latency and hops. So with that, I leave it to you for any questions or comments.
Hello, I'm Lydia with Fermilab. So I'm somewhat new to using Condor and Glidance. What's the significance of their location and, let's say, either physical or network hops to where they end up running? Is the significance that there's a lot of data that needs to be transferred out, or is there something else? Thank you.
I think there could be a lot of reasons why we want location and just dependent on what we're trying to do with that use case. Like from Todd Tannenbaum's presentation, if you notice that there was a bunch of unknowns in his site, that's the best way to put it. Yes. A lot of that is missing information. So that could be an absolute location that we could try to automate and autonomously figure out. But then we also can try to this is an idea, don't take it seriously, but I could try to optimize how caches and Glidance work in relation to each other, but there's a lot of problems that could relate to that, but there's something like that idea. So, but then the ideas go on for a lot more than that too.
Have you run into any situations yet with your use of tracepath or traceroute where somebody might be using an overlay network and the number of hops you're running into isn't really related to the physical location?
What is an overlay network? Okay. I can answer that when I figure it out.
Oh, I was just curious if as part of your work, did you measure latencies to the caches?
Just measuring the time. It's returned back from trace route and trace path itself. So I guess that is my way of measurement, if that makes sense. Yeah.
Oh, okay. But not like latencies like actually measuring like downloading file or something.
No, it's just to something.
Yeah, maybe a sort of naive question. How do you resolve like ambiguities? Like if you have two sort of sites that are like equidistant from whatever position that you've sort of pinned down.
Can you repeat that?
Like how do you resolve ambiguities? Like if you have two options, how do you know which one is the right one?
I guess what are you defining as these two different options? So right now I'm just defining it as the glide in itself. So
right. I'm saying that if they're the same distance away, like you define the distance, right?
Yeah. Using
network latency and hops. If there are two, sites that are equidistant, how do you know which one's the right one? And I guess a follow-up question to that is how important is it to know this information accurately?
I guess so that I haven't done that part yet, but I could answer that as I could take in that information I have for latency, but I think I'd have to involve a lot of other aspects to what's happening and like the whole entire OS pool. Now these resources are actually being overloaded. There's a lot more information I should take in.
Okay, thank you.
Yeah.
We still want to keep the lightning in the lightning talks. These are great questions. Neha, who's next?
So our next fellow is Finn, and he will be presenting on machine learning stuff.
Hello, my name's Tin. For this summer, I've been working with Justin Hiemstra on machine learning for the OS pool value classification. I would like to start with an example. So let's say we have a user that's trying to upload a job onto OS pool. And right here, the job starts in the idle state, and then it transitions to the run state. However, when it's executing, something happens that forces Condor to put it into a hold state. And now it's up to the user to decide whether to release the job so that it can run again, or to remove it and put it into history. Our goal is to make a machine learning model that can make this inference on behalf of the user in hopes that we can reduce the number of occurrences where a user released a job, but really they should have removed it. This would free a lot of compute resources. Yeah, so that's what our problem that we're trying to solve is. And I would like to discuss why we're using machine learning for this problem. Mainly it's because the OS pool is a complicated network of nodes that's constantly changing through time. And it just makes sense to use machine learning and let it learn all the temporal patterns that are changing through time without us having to interfere with it too much. So let's say we have a model that can make the inference. How would the user actually use it? So going back to the previous example, the job is in a hold state and the user is connected to an access point. And this is their command line interface. They would simply run the tool. Let's just call it inference for the sake of this example. So they provide the job ID and the log file that was generated when the job was submitted. So given this information, it will just spit out a binary output. So let's say the user should release the job, maybe because the site was having some problems. There was a thunderstorm, and now the basement is being flooded. So the staff's trying to get rid of the water, or the user should remove it because the model detected some kind of indicator that lets it know that the job is the fault rather than some sites. So that would be the output of the tool. And so how would we actually implement this? So far, as I briefly mentioned, the log files, that's what we're mainly working with. We're parsing them into a time series data formats and then labeling them. And given that, we're just feeding into a model. So currently we're working with what is called a long short-term memory neural network. I don't really understand too deep into the architecture. All I know is that it understands temporal pattern. So I just feed it data and hopefully things works out. So I guess in addition to this inference, we hope at the end that we can add something like, in addition to the inference, the model should be able to provide additional context as to why the job may have gone to hold. And this would help the facilitators debug the sites as well, in addition to being useful for the users. That's my lightning talk. Are there any questions?
It's a great talk, thank you. As somebody who does research that is AI adjacent, but not quite, I'm surprisingly suspicious of when it is great to deploy machine learning for use cases. So I'm gonna ask you a hard question that you might not be able to answer, and that's okay. So you mentioned that you could use machine learning to save cycles, right, by doing inference.
Yeah.
I wonder how true that might be, given, AI search, for example, in web browsers and search engines is actually ridiculously more expensive than plain old search. I wonder if you have considered comparing sort of a static policy implementation based on inferences. You train it once, now it's a static policy, versus sort of continuous compute being spent on these inferences, what the difference in cost might be, whether that be cycles or the electricity bill.
Okay, I haven't thought about doing that kind of comparison, mostly because I've only really considered continuous training. I just can't see how a model can, I guess, make an inference farther in time as like the environment changes and the model becomes more and more outdated. So, yeah.
As you've been classifying failure types with the model, I'm presuming you've got some statistics out. What percentage of the failures are hardware or software related versus how many are human related? as you're classifying failures?
I don't have the statistics, but I do have a process on how I'm classifying them. So we're looking at global event logs, and we're filtering out, or actually we're only looking at jobs where it went to the hold and then idle state. And then among those jobs, we're asking the question of whether they eventually succeeded normally or they terminated abnormally with some kind of weird error code. And so those are the main two labels that we feed it to the machine learning model. So with that, we can ask a question: if we were to run this, what's the likelihood that would actually succeed? Yeah.
Fair enough. I was just trying to figure out how many people were at fault for their own problems.
Okay, thank you, Tim. Let's move on. Round of applause.
The next fellow is Patrick.
Hello, everybody. I want to start by thanking both Jason and Brian for introducing my talk a few times before even meeting me. So, so my talk is focused on, well, actually, first of all, I'm Patrick. I am a student here at UW-Madison studying computer science, and my mentor is Hao-Meng Meng, and these are my two dogs. So currently there's an issue, and the issue is that diagnosing a pelican or like an origins health is really difficult. And so the reason being is that there's all sorts of services that are at play and that could cause all sorts of failures, and maybe not complete outages, but there could be kind of unhealthy states. And so there isn't great tooling at the moment to understand what might be healthy, sick, and dead. And so a Pelican origin is kind of the backbone of a federation. You know, we've seen the architecture several times today, but it connects and serves an object store out onto a federation. And so if an origin is down, that means the data it was serving is also down, because the staging device or a cache wouldn't be able to access the data. It is trying to, if there was a miss, it's trying to serve out. And so, like I said, it's difficult understanding why there's failures at the moment. So this is another architecture diagram, but this is an origin. And so Pelican uses a few different services. The one we use for collecting our metrics and collecting our metrics and storing the metrics is called Prometheus. Prometheus normally runs as an external service, and usually its own world isolated away from everything else. We integrate it as a library within the Pelican origin server. And so this has some interesting implications. Alongside that, we use XRD as the main driver of serving up an object store, and the origin simply makes that object store available across the federation. And so there's a lot of implications of what these different parts mean. When they're down, there's implications of what that means for the origin itself. So if XRD is down, then the object store that we're trying to interact with is also unavailable to us, and thus the data isn't available for us to serve out, which isn't good. And if Prometheus goes down, which would mean that we're running out of memory, or we can't store enough metrics on disk somewhere, we can't, there's an outage in our metrics. And so because of the integration of Prometheus and the origin, that could also mean that everything goes down, because when Prometheus goes down, so does the origin. And so in the current web UI, this is what we see, which is, we see in the top, we see a status, which kind of indicates different service kind of errors and health. And then we also see the transfer rate. Now, currently, this is quite limited in terms of understanding more than just what's going on in this surface level. You can imagine there could be all sorts of important things that a sysadmin or maybe a user might want to know beyond just this stuff. And so I, with several sysadmins from the CHTC and the OSDF, collaborated and had a user study where we talked about what are some of the issues and some of the things you want to see within the web UI. And so I designed a mock in Grafana. And so there's 3 different panels that I'm going to be going over. And so in this first panel, it's the overview. And the overview is similar to what you saw before on the original web UI, but you can see things like the transfer rate and the project's byte access and the storage usage. And the two components above that are the component status, which is similar to before, and the server status, which is just like, when if there's a critical error in any of the services. And we can also see a resource utilization, more advanced view, and beyond. And so beyond that, you can see these big red bubbles which show data outages. And this is when Pelican is down. And so if we were to generate reports about maybe how often an origin is being accessed or what files are most popular, and we were trying to do an aggregative view and we were reporting that without saying there was an outage, that could be an issue for some end user like the NSF looking at statistics. And so we want to be able to report these outages to our end users. And so what's next is I'm going to be implementing more metrics, and then I will also be alerting users of any potential things like we're running out of memory or storage or anything like that, and then reporting metrics to the end users. And that's all. Thank you. Okay.
I'll throw you the question. So when you're doing the reporting, are you thinking about implementing something where somebody can subscribe what they care about? i.e., some might be worried more about memory, some more about outages, some more about CPU utilization at particular locations.
Sure. So the reporting idea right now is very much in a draft kind of stage. And so I definitely agree with you that the idea of being able to subscribe to maybe different metrics that might be important to some end user is valuable. Because, the NSF might not care about memory usage, but they might care about how many objects are being stored. So I definitely agree with you.
I was wondering, if you have any plans for having sort of like an alarm system where, if something goes down, they can subscribe to an app or something and you get a notification that this is down.
Yeah. So Marone and I and Hao Ming had a meeting together. And so Marone had mentioned that he gets an email every morning about the status of Condor in the OS pool and all, well, probably many emails, but an email of reporting. And so I'm sure, and Marone showed interest that he would like an email of sorts showing important statistics like that. So I'm sure that that's the end goal of providing some sort of email reporting on an annual or daily basis. So.
Quick question. So you're running Prometheus, the server that stores the metrics on the origin.
Yes.
How is that to deploy and package? Is it just like one Go binary and that's the whole thing, or is it a big mess of stuff?
So it's funny. So Prometheus normally is distributed as a binary, and that gets or in a container or whatever it may be. However, the programming language that the origin is written in is the same as Prometheus. So we actually use Prometheus as a library. So we say all the packages that you're open sourcing, we're actually integrating them and kind of scrappily hodgepodging together a Prometheus server with inside of.
Got it, because it's all in Go.
Yeah.
But Prometheus standalone, if I grabbed it, is it just like one binary and you just run it?
Yep. Yeah, exactly.
Okay, thank you. Should we move on and give Patrick a big round of applause? I think our next student is Christina.
Hi, everyone. My name is Christina, and I'm a summer fellow here in CHTC. And my mentor is Ian Rose, and I'm a tourist key. And today I'm going to introduce my project, integrating Pelican with PyTorch. So let's start with an introduction. Through the session this morning, I think everybody is familiar with Pelican right now, which is a platform to federate data together and deliver them to the compute capacity. And PyTorch is a very popular machine learning tool. And then HTC24 is the tool which can help us to run our jobs on the OS pool. And here's a graph show a standard workflow. We can see we first grab that data from the Pelican origin, and then the dataset class from PyTorch will store the symbols and their corresponding labels. And then the data loader will turn the data samples into batches, and then it will be ready to train. So what the problem? When the things is small, everything will be easy. You can just download the data to local and train on it. However, when it's becoming larger, there will be challenges, especially the data is on remote. So for example, what if your disk is smaller than the data set? It makes you unable to download them at once. Although your disk is big enough, you don't want to wait for downloading a big data set. It may take hours or days. So at this time, your GPU will be idle. We don't want to see this kind of waste happen. And also, at the same time, how can we keep low latency and high data throughput in the same time? So our goal is, first, we want to streamline the workflows. Before, we can only use the CLL tool of Pelican to fetch the data from origin. So in this way, you need to download the data first and train the model using Python separately. However, after my mentor wrote Pelican FS, which implement the FS-backed. So FS-backed is a Pelican specification of the file system interface. With FS-backed, you can access the file system, which is remote, access it just like it's a local one. So you can use the same behavior to access different backend. So with this, you can using a Python script to access the data and download it or start training it immediately. I can remember when I start deep learning, you always wanna focus on the model. However, you need to spend a lot of time on the tools. So I think as an AI researcher, they wanna focus on the model. So we hope they spend this time on the tools. So we hope to make the tools easier to use to make the integration more smoother. So our final goal is make our AI researcher happier. So how should we achieve all of this goal? First, I would do a lot of research on Pelican FS-backed, like how FS-backed open the file, how PyTorch consume the data, and also I will know about the real-world scenario. What kind of field format that the machine learning researcher always use, and how's the field size like, and how's the resource, and does the resource have any limitation? And then I will start benchmark. I have done benchmark on a small data set, which is only 150 megabyte, and switching to a much bigger one, which names ImageNet, and it's 150 gigabyte. So when the model is very small, loading data from the remote source can significantly lower the training. However, after you model maybe have millions of parameters, the GPU will take a long time to train it. So at the same time, you can load data. So the Pelican data access won't be a bottleneck. And by benchmark, I think researcher will have a rough idea of the performance of different ways of loading data. So they will have an idea before they start using Pelican. And then we only know there are some problems when we start implementing it. And when I tried to train on the ImageNet, I found the image folder in PyTorch very useful. If your data is well structured, it can grab the image and label it automatically for you. However, the root parameter here do not accept remote paths. It only accepts local paths. So I implement a remote image folder by myself. I think this kind of tools will help. Should I stop? Will help the AI researcher more conveniently to using with Python dataset. Finally, we will do, and also Amazon S3 have their connector for PyTorch. So we think it's a good idea for us to do something similar. And finally, we will do tutorial and documentation to help the community adopt Pelican as a training tool. Yeah, so that's all. And as I'm not an AI researcher, if you are an AI researcher and meet any problems when using Pelican or HT Counter, I'm happy to talk with you and to try to solve these problems. Thank you.
I think this is great. I'm actually working on something, a different architectural approach to solving the same problem. So I think this is great, and I'd love to talk to you a little bit more. I could help you test this on one of our origins with data. So.
Oh, I'm excited.
Excuse me. So your main goal was making AI researchers happy, but through your project plan, I don't see anything about talking to the AI researchers. Do you have any plans to survey any for feedback or anything like that?
Yeah, so this is what I do last, like to let AI researcher talk with me. So when I just started the project, I was very confused because they just told me to integrate Python with integrate Pelican with PyTorch, but I don't know how. What should I do specifically? So I really wanted to hear some story, like an AI researcher using something and they maybe have some pinpoints or they think something can be improved. So it's kind of like the user studies. Yeah, I really hope to hear more stories from others.
Thank you, Christina. Great talk. The next speaker is Pratham. It's not going forward. Oh, there's a lot. Oh, I see. Okay, thank you. Okay. Hello, everyone. My name is Pratham, and I'm a fellow here this summer, and I'm going to be talking a little bit about enhancing the building of the OSG container images. So before getting into my project, I just wanted to share a little about who I am. I'm originally from Beloit, Wisconsin, which is an hour south of here. I will be a senior this fall at UW-Madison studying CS and DS, and I'm pretty awesome. All right, now getting into the meat of the topic. My project is enhancing the OSG container build system. So CHT currently builds images for sites to run and that we use internally. A lot of these images are based on upstream OS container images, and we build these images at least once a week. So the main focus of my project is to add versatility and streamline the build process for these images within this OSG repository, and we're going to use a three-phase approach to do that by adding customizable build instructions for each image, using dynamic triggers for external repositories, and hopefully being able to add compatibility and support for ARM-based systems. So a closer look into like what an image consists of. We have an image X here within our repository, and it contains these build parameters, software, its versions, and these parameters are multiplied together, and we get when we get a certain number of builds per image based on the parameters that are being based on the parameters that the image is being built for. In this case, for image X, we are building the image based on the parameters that you can see up on the screen. And a lot of times this causes a lot of images to be built that we don't actually need. So they're just redundant. And if we multiply this across all of the images that are currently in the repository, it becomes a big problem because we have, I think it's 27 images in the repository. So we have a whole lot of redundant images being built. A little background on how the current build process is. The GitHub Actions workflow automates the building and pushing of these container images, and it's triggered by specific conditions and events. The design is very monolithic. It lacks flexibility in the build process. So all the images are being built using a single unified workflow, and currently there's no support for ARM architecture. So what the project is requiring and what I'm attempting to instill is to add versatility. So the system currently needs to allow, or the system needs to allow the process of building these images through a unique, or I'm implementing a unique configuration file with parameters that can be changed to build each image. And if that file doesn't exist, then we could default to some backup file to build these images. I'm
attempting to add a trigger mechanism located somewhere in the images repository, which activates updates with Pelican and hopefully other external repositories. And finally, I'm also going to be attempting to add ARM compatibility for these images. So the first phase of this project, my objective was to make it so that I could build these images with any parameters that I would want instead of parameters that are hard-coded into building these images that cause these redundant images to be built. Phase 2, which is what I'm currently getting into, is hopefully being able to create some sort of trigger in the images repository and using GitHub Actions to monitor and trigger Pelican and other repository when updates are needed. So to conclude, my project consists of 3-phase approach. Hopefully at the end, I'll be able to enhance the flexibility, efficiency, and future readiness for building these container images and adding custom build instructions, trigger for external repositories like Pelican for any updates. And I would really hopefully like to get to adding ARM-based support. Yep, that's pretty much all. So thank you.
So first question. So you're talking about doing testing. So when you're building a new image and there might be software that's associated with, so I saw EL7 and EL9 and there's new software updates for it. How are you running your testing? That is, do you have a suite that measures performance for a particular set of benchmarks that you care about and have acceptance, or and that's just performance benchmark testing. I'm also thinking about functionality. So recently we ran into a situation, for example, at our institution where we were updating compute nodes and compute images, and SSH broke with the recent regression vulnerability that we were trying to patch against. So how are you functionally testing images to make sure they're actually working with what you updated to?
So I haven't gotten to functionally testing images. I'm more so just worried about being able to build these images with customizable parameters. So I don't honestly know how to answer the question on like testing if the images are actually working after these custom parameters are built after they're built using the custom parameters.
Fair enough. Just consider the idea then of having like a suite of tests that you would run as part of your workflow as you're running through with parameters, and then it ingests, say, some suite of software and it goes against a baseline.
Okay, thank you.
So I might be against what I'm about to say, which is really interesting, but why do you have to automatically always push these images? Why can't you do it manually if this doesn't seem like the images are always changing?
So from my knowledge, the way the images are built do change, but I believe that since many people are changing them and they need to be triggered to be built automatically over time. I also feel like if you are manually pushing it every time and you forget to push like an update and build, then that would just not be optimal.
Thanks. I enjoyed your talk very much. I went through a similar process last year for some containers I'm responsible for, and I looked at AWS's code build and code pipeline. I looked at GitHub workflows, and the whole time I kept thinking to myself, man, I wish I could just use Condor Dagman. It's so much better. Yeah. Are you guys using local infrastructure to do the builds, or are you actually building on GitHub or building in AWS?
I'm building on GitHub, just using GitHub Actions.
For the ARM stuff, we're gonna have to use the CHTC.
Get to. Yeah, I haven't gotten to the ARM stuff yet, so.
To manage builds.
Thank you, Pratham. That was great. I think our next speaker is Ben.
All right. Hi, everyone. Let's see. My name is Ben Staley. I'm currently a student here at UW-Madison, majoring in computer science, as you may have guessed. Currently I'm fortunate enough to be part of the CHTC Fellows Program, and I'm working on the Tracking Server Inventory and Elevation project with my mentor, Joe Barkoyak. And so I think a good place to start is what problem are we solving? And basically, at a very low level, the CHTC has a lot of stuff. So we maintain more than 1,200 assets spread across 5 data centers here in the Madison area. And those include servers as well as other things like switches and routers, but we're talking mainly servers. As well as the PATH facility, which maintains assets other places such as Nebraska, Florida, New York, and is some here in the Madison area as well. And so as you can imagine, servers tend to move around, they change purpose. And so it can become quite a time-consuming job for the people responsible to keep track of all these assets. And so since these are mostly technical assets, mostly very expensive servers, they end up all in locked server rooms. And so our system administrators are the ones who mainly have access to these. And so it makes sense that our system administrators are the ones who are responsible for maintaining our inventory records. And so additionally, we purchase our assets through external stakeholders like UW-Madison and the Mortgage Institute for Research. And these organizations also keep their own records for accounting purposes, for example. And so for that purpose, it's important that we also keep updated records here at the CHTC. And so our current system of tracking assets is a spreadsheet that's manually updated by our system administrators. As you might be able to imagine, a giant manually updated spreadsheet updated by our very busy system administrators maybe isn't our ideal solution. So the next question is, how do we solve the problem? And so in a sentence, we want to try to move our data closer to system administrators. And so one thing to understand is that our system administrators spend a lot of time interacting with their configuration management system, which consists of a set of YAML formatted configuration files that are in a Git repository. And this is nice for a couple of reasons. First of all, YAML is pretty easily extensible, and also we get all of the niceties that come with Git, so conflict management and history and all that. And so basically, we're going to move our asset data into Git tracked YAML files. And so as part of our plan to help us with this, we have a series of Python scripts that will do things like data entry, decommissioning old assets, as well as validation, and as well as some external integrations too. And so sort of one thing we've encountered on this project so far is data validation and making sure that we have accurate data, because otherwise that kind of lessens the point of keeping these records. And so we are developing a script that will hopefully sort of find some of these invalidities and make our system administrators aware. And sort of another thing we're working on is some external integrations. So one example is Google Sheets. So I think it's reasonable to assume that sort of more non-technical folks may want to look at this data in a spreadsheet instead of digging through files. And so that's kind of one of the things we're working on as well. And sort of one other big thing that we've kind of approached on this project is thinking about our data design. And so we sort of came into it with the idea that our whole data design was very centric on this idea of an asset, and then everything else was sort of secondary. And sort of as we went along, we found a lot of value in looking at it from other angles, for example, location or acquisition event, and sort of we sort of developed this diagram and iterated it to get a better idea of the problems we're working with, and also to try to help us better understand some of the complexities that the project deals with before actually implementing them. And so I think that was quite valuable. So with that, I think that's all I have. I'm happy to take any questions. So thank you.
I'm interested in the technology decision of using what would you say, Git track YAML files as inventory versus Netbox. Like a web interface that you could query and have asset tags and elevations, and there's alternatives in Netbox as well. But
For sure, yeah. And that's a something that we've talked about too. And I think for us, it kind of came down to we wanted something that was more convenient for our system administrators, something that was sort of worked well with workflows that they already have, and that would be easy for them to update. So hopefully in the future it gets used and we're able to keep it.
So what you're saying is your sysadmins live in Emacs and Vim. Gotcha.
More or less.
Just one of those. I'm not going to say which one. Just one of them.
So I'll ask the easy question of, can you also have other assets besides text? So for example, can you take a picture of the thing where it is, as well as say the ASIC tag of the item? I'm also sitting here thinking of, what are your other consumers? Have you thought about like internal audit? I know that, for example, at our institution, if it's an asset is greater than $20,000, every however often somebody from internal audit has to come by and take a look at it. And I'm thinking about like a 3D visualization cube that cost $1 million that had an asset tag in the bottom left corner next to the floor.
Yeah, so I think if I understood right, we currently don't have any way of having other data like pictures, but that is a good point. And I think sort of as far as other organizations, that was kind of if I go the right direction here. That was kind of, we left it sort of open with this sort of downstream consumer stuff. And the idea was maybe in the future, if a need for something like that were to arise, that we would implement the project in a way that it would be easy to do something like
that. Thanks, Ben. Do we have in CHTC any assets that do not have a host name?
Sorry, that don't have a
host name.
A host name. That is a good question. So we do. There are a couple. Trying to think, I can't think of an example off the top of my head, but I know there are a couple, and I think for now we sort of were bypassing those. But that is a fair point, considering that the names of our files are contain the host name. So.
Okay, thank you. Let's give a big round of applause for Ben. Our final speaker is Will.
All right, hello everybody. I'm Will. I've been working under Greg Thane on performance monitoring in the SCED, and I know that doesn't mean much to you right now, but hopefully if you're an admin or even a user, I'd like to kind of tell you why this might be important to you. So essentially, on every access point, the SCED is a process within the access point that kind of handles a lot of user commands like condor Q, condor submit, and condor rm. And the problem we've been running into is that sometimes it kind of randomly slows down with no warning, no error, no nothing. And our task is to find the root cause of that slowdown and ideally fix it. So we want to communicate to the admins what or who is the problem. And I'm going to start off by defining some terms here. A task is an object that has an associated time cost that it's going to take to process. And a queue is an object that's going to accept incoming tasks one by one and work on them. You can think of a queue as the line for an amusement park ride. Each person in the line would be a task that you have to operate on, quote unquote. So kind of our general problem here is that we have a queue with n different categories, and this queue is going to record the total amount of time that we spend processing each category. So how can we kind of get the instantaneous state of the system from only these total data points? So this is where sampling comes in. We're going to kind of every 5 seconds, every 10 seconds, we're going to take a sample and we're going to diff the runtimes. We're going to do the new runtime minus the old runtime. And that'll see how much time we spent in this category in this window. And then we can divide each category time by the sum of kind of the total runtime. And this gives us a relative proportion. Then we can give a fancy pie chart to the NSF or whatever. And this will tell us what's taking up a majority of the time in the SCED, or the queue, I should say. Sorry, spoiler, the SCED is a queue, essentially. It operates on tasks one at a time. We have categories like handling commands, handling jobs, writing to disk. and we publish the totals of these commands through class ads that you can query yourself. So it should be pretty trivial to write a command line script that can give you the breakdown. Here you can see we have the commands category, and I am running some commands. So there's just one problem. How are we getting that CPU time? And it is not exactly so easy. So the internal HT Condor system is going to publish a 20-minute average of the percentage of time that the CPU has been busy for. So you'd think the naive solution is that we just multiply by the window size, and that gives us the CPU time over the window. And if the percentage is relatively stable and traffic has been kind of slow and steady, that works just fine. You can see we have jobs have been handled pretty steady by this test user, and everything kind of checks out here with all the categories. Notice that that other category at the bottom is 6%-ish, and that is the kind of commands that we can't track internally, so we just leave that as a black box for the user. So the problem is that if we have a heavy spike in traffic, this average is going to fall way behind what we're totaling, and we're going to end up with something like this. And essentially, you can see the other at the bottom is 0% there. We have to renormalize because the totals that we're getting are so much higher than the average. We have to trust our own totals. And as a result, we kind of lose a lot of information in the process. So next steps for doing this performance monitoring, I want to improve visibility at a glance. So instead of having a icky command line interface to look at, maybe have a fancy chart so you can see the full breakdown of commands and the users who are running them. I want to have more process coverage, and that would result in reducing the other category to 0 in an ideal case, so we can see exactly the entire breakdown of the system. And then finally, give more intelligent warnings to users. So instead of just getting this whole breakdown, maybe just tell them right out the gate, this user, Condor Q spammer, has taken 25% of the CPU time for the past hour. Maybe put a stop to that. And that's everything.
I have a question. So I'm guessing this is the case, but just want to confirm. So when you're querying and getting this information, I'm assuming that's not another task that gets added to the queue? Or is this, are you?
Unfortunately, it is recursive, yeah. So the time it takes to process your query is included in the next sample window.
Okay, just curious. Thank you.
So maybe to connect it to Patrick's presentation where he's talking about instrumenting XRD and Pelican, and then using the Prometheus toolset to kind of push out the metrics and handle visualization and calculation of these quantities. Would it be possible to dump this out into a Prometheus compatible format so you can, instead of having to do your own visualizations, leverage something else that exists?
I think it would be possible. It depends on how many SCEDs Prometheus can manage at one time, because we're taking the stats on each individual SCED and it doesn't really make sense to aggregate them. But that might be something to keep in mind, I guess.
Yeah, something to talk about next week.
Here's a question about this last maybe don't let them do that point here. So to make a dated reference, it's 3 a.m. and Condor Q spammer is blowing up the queue. Who's going to answer the phone to stop them from doing that?
This is a non-ethical question.
Cruel and unusual punishment.
So I was actually thinking along similar lines. So the SCED, right, already has a notion of how overall busy is it, right? It's called the recent daemon core duty cycle. This is, how much time is it handling events versus how much time is it sitting around waiting to, doing nothing, right? And, we have found that the SCED is responsive and everybody's happy until the duty cycle gets in like 99% or above, then things go down quickly. So maybe you could take a Vulcan approach. The needs of the many outweigh the needs of the few or the one. And if the daemon core duty cycle is above 99%, whoever is your most guilty one user, you're just like, sorry, bud, see ya. And then everybody else can merrily chug along, until people get in at 8 in the morning instead of coming in at 3 a.m.
Yeah, that could definitely be a solution. We've mostly been working on kind of external stuff because we're the people querying the SCED, but yeah, internal changes could definitely happen too based on this output.
Okay, thank you very much. Let's give a round of applause for Will and all of our fellows.